All right, let's dive into some chemistry today.
Okay.
We're going deep into acids, bases, and salts.
Sound good?
And no worries, this isn't going to be a boring lecture.
Right.
We're going to be talking about chemistry that's happening all around you,
Yeah, exactly. It really is.
from the kitchen to your own body.
Uh-huh.
Pretty wild, huh?
It is.
So, you
You're
ready?
ready?
I'm ready. Okay, let's do it.
Okay.
All right, so,
Yeah.
acids, bases, salts,
Mm-hmm.
what exactly are they?
Well, at their core, they're all about ions.
Oh,
When you dissolve an acid in water,
uh-huh.
it releases hydrogen ions,
Okay.
kind of like tiny little charged particles.
Mm-hmm.
Bases, on the other hand,
Yeah.
release hydroxide ions when mixed with water.
Okay.
Think of them as chemical opposites,
All right.
constantly battling it out.
So how do we know which is which?
Yeah.
Like, I vaguely remember litmus paper from school.
Yeah.
Does that still apply?
Litmus paper is definitely the classic way to test. It turns red in acid
Yeah.
and blue in base.
Mm-hmm.
But what's fascinating is that you can find natural indicators all around you.
Mm.
Did you ever get a turmeric stain on your favorite shirt?
Oh, don't remind me.
Yeah.
That curry stain.
Was that
It was
really-
a nightmare.
That stain's actually a chemistry lesson in disguise.
What?
Turmeric is a natural indicator.
Really?
When you scrubbed it with soap, which is basic,
Yeah,
the stain probably turned reddish-brown.
it did.
And then when you rinsed it with water,
Uh-huh.
it went back to yellow.
Yeah.
That color change is all thanks to the turmeric reacting to the different pH levels.
No way.
Yeah.
So I was doing chemistry without even realizing it.
Exactly.
Wow. That's pretty cool.
Yeah.
What about other everyday stuff?
Well,
How can I tell if something is acidic or basic?
taste can give you a clue.
Okay.
Acids generally taste sour,
Mm-hmm.
think lemon juice or vinegar.
Yeah.
But of course, I don't recommend going around tasting random chemicals.
Okay. Fair enough.
Yeah, don't do that.
I'll stick to tasting food. But speaking of reactions,
Right.
the textbook mentions some pretty cool interactions between acids and bases and other substances.
Yeah.
Didn't it say that when an acid reacts with metal, it creates hydrogen gas?
Exactly.
Is that right?
Picture this. You drop a piece of zinc into sulfuric acid.
Okay.
Suddenly, these tiny bubbles start furiously fizzing up.
Yeah.
That's hydrogen gas being released.
Mm-hmm.
This reaction is actually what makes certain batteries work.
So the same reaction that powers batteries is happening when acid corrodes metal.
Exactly.
That explains why my grandma always insisted on using glass jars for pickling.
Yeah, acids can be pretty powerful stuff.
Wow.
But let's move on to another exciting reaction.
Okay.
The kind you see when you mix baking soda with vinegar. Ever wonder why it fizzes so much?
Honestly, I've just accepted the fizz as part of life.
Sure.
But now I'm actually kind of curious. What's
Okay.
going on there?
Baking soda, which is sodium bicarbonate,
Mm-hmm.
is what we call a base.
Hmm.
And when it comes into contact with an acid, like the acetic acid in vinegar,
Uh-huh.
it releases carbon dioxide gas.
So that's what creates all those bubbles.
Exactly.
So every time I bake a cake,
Yeah,
I'm basically conducting a chemistry experiment.
you really are.
This is making baking way more interesting.
It really is.
And speaking of baking,
Yeah.
this same reaction is what makes cakes rise,
Uh-huh.
right?
Baking powder contains an acid that reacts with the baking soda,
Okay.
releasing those bubbles that give cakes their fluffy texture.
Interesting.
But did you know that the type of acid used in the baking powder can actually affect how high a cake rises?
Hold on, I need a minute to process this.
Okay,
So the type of acid determines how fluffy my cake is.
that's right.
I never thought of it that way.
It's true.
Okay.
Different acids react at different speeds,
Uh-huh.
which can impact the final product.
Hmm.
But we'll save the baking chemistry for another time.
Okay, deal.
There's another crucial reaction we need to discuss.
Okay.
Neutralization.
All right.
This is when an acid and base completely react with each other,
Hmm.
resulting in salt and water.
So antacids, which neutralize stomach acid,
Yeah,
are basically just a carefully controlled acid-base reaction.
you got it.
That makes sense.
Antacids provide relief from heartburn
Uh-huh.
by neutralizing that excess acid in your stomach.
Okay.
It's all about finding the right balance.
That reminds me, the textbook also talked about the pH scale.
Yeah.
What exactly is pH,
Right.
and why is balance so important?
Well, the pH scale is like a chemical rainbow,
Okay.
with different colors representing different levels of acidity and alkalinity.
Mm-hmm.
It runs from 0 to 14,
Okay.
with 7 being neutral, like pure water.
Yeah.
Anything below 7 is acidic,
Mm-hmm.
and anything above 7 is basic or alkaline.
Okay, so where do some of our everyday substances fall on this chemical rainbow?
Sure.
Like, how acidic is stomach acid?
Stomach acid is incredibly acidic,
Yeah.
with a pH around 1 or 2.
Wow.
It needs to be that strong to break down food, but even small changes in pH can have a big impact.
I'm starting to see why balance is so important.
Yeah.
Too much acid in your stomach, you get heartburn.
Right.
But what about other parts of the body?
Oh, well, take your teeth, for example.
Okay.
Tooth decay starts when the pH in your mouth drops below 5.5.
Really?
Bacteria in your mouth feed on sugars and produce acid,
Mm-hmm.
which can erode the enamel on your teeth.
So that's why brushing our teeth is so important.
Exactly.
It's not just about getting rid of food particles, but also about neutralizing that acid before it does any damage. But wait, I thought sugar was sweet, not sour.
Yeah.
How is it acidic?
That's a great question.
Yeah.
The sugar itself isn't acidic,
No.
but the bacteria in your mouth that feast on sugar
Okay.
produce acid as a byproduct.
So it's like a chain reaction.
Kinda.
That is sneaky.
It is.
This deep dive is already full of surprises.
Yeah.
It's amazing how pH plays a role in so many things,
Uh-huh.
from our bodies to the environment.
Absolutely.
So,
For instance, soil pH is crucial for plant growth.
okay.
Different plants thrive in different pH ranges.
Mm-hmm.
So if you're a gardener, knowing your soil's pH can help you choose the right plants
Oh, that makes sense.
and make sure they grow healthy and strong.
So you're telling me that even gardening involves chemistry?
It does.
Wow.
Yeah,
I'm starting to see chemistry everywhere now.
you are.
But speaking of the environment,
Yeah,
didn't the chapter mention something about acid rain?
it did.
That sounds pretty scary.
Acid rain is a serious environmental issue.
Yeah.
It's what happens when pollutants from burning fossil fuels
Okay.
react with water and oxygen in the atmosphere,
Mm-hmm.
creating sulfuric and nitric acids.
Wait, so you're saying that pollution actually creates acidic rain?
Exactly.
How does that even happen?
Imagine those pollutants, things like sulfur dioxide and nitrogen oxide, floating around in the air.
Uh-huh.
When they combine with water molecules and oxygen,
Mm-hmm.
they undergo chemical reactions that transform them into acids.
So it's like a giant airborne chemistry experiment,
Right.
but with some pretty awful consequences.
It is.
What kind of damage does acid rain cause?
Acid rain can have a devastating impact on the environment,
Okay.
especially on aquatic life.
Hmm.
When it falls on lakes and rivers,
Yeah.
it lowers their pH,
Okay.
making it difficult for fish and other organisms to survive.
Whoa, wow.
Some lakes are so acidic
Yeah.
that they look crystal clear,
Really?
but that's because nothing can live in them.
That's really alarming.
It is.
It makes you wonder what we can do in our daily lives to reduce acid rain.
Yeah, it's definitely something to think about.
All right, well, let's shift gears
Okay.
and talk about the last member of our chemical trio,
Sounds good.
salts.
All right.
Are we just talking about table salt here, or is
No.
there more to it?
You're absolutely right.
Okay.
Salts are a vast family,
Mm-hmm.
and they're formed in many of those reactions we've been discussing.
Yeah.
Remember how acids react with
Yeah.
metals,
Mm.
releasing hydrogen gas?
Like that zinc and sulfuric acid example.
Exactly.
Oh, okay.
The other product of that reaction is a salt.
Hmm.
In fact, sodium chloride, which is our common table salt,
Okay.
is a key ingredient in making a bunch of other useful substances.
Wait, so you're saying that the same stuff I sprinkle on my fries is used to make all sorts of chemicals?
It is?
How does that even work?
Well, for starters, sodium chloride is used to produce sodium hydroxide,
Mhm.
also known as caustic soda,
Yeah.
through a process called electrolysis.
Mm.
And as a bonus, this process also generates chlorine gas,
Okay.
which is used to make bleaching powder.
Hold on, so common table salt is a building block for bleach?
It is.
That's wild.
Yeah.
What else is it used for?
The list goes on.
Okay.
Baking soda, which we talked about earlier,
Mhm.
is also made using sodium chloride.
Hmm.
And so is washing soda,
Okay.
which is used for cleaning and softening hard water.
Wow. Common salt is way more important than I ever realized.
It is.
It's like the unsung hero of the chemical world.
You could say that.
And there's another fascinating aspect of salts that we need to explore.
We do.
Okay, I'm all ears.
All right. Right.
What else is there to learn about salts?
Well, have you ever heard of the water of crystallization?
Water of crystallization?
Yeah.
That sounds intriguing.
It might sound a bit mystical,
Okay.
but it's actually pretty cool.
All right.
Many salts, even though they appear dry,
Uh-huh.
actually have water molecules trapped within their crystal structure.
So it's like the water is hiding inside the salt crystals.
Exactly.
Interesting.
A great example is copper sulfate.
Okay.
If you heat copper sulfate crystals,
Hmm.
they lose this water of crystallization
Okay.
and turn white.
Mm.
But if you add water back to the white powder,
Yeah.
it turns blue again
Oh, wow.
as it reabsorbs the water molecules.
That's amazing.
It is.
So the color changes all thanks to the water molecules.
Exactly.
Like a chemical magic trick. Are there any other examples of salts that do this?
Absolutely. Gypsum is another good one.
Right.
When you heat gypsum, it loses water molecules
Okay.
and becomes something called plaster of Paris.
Wait a minute. Plaster of Paris, like the stuff doctors use for casts?
That's the one.
Wow.
Plaster of Paris is essentially dehydrated gypsum.
Okay.
When you mix it with water, guess what happens?
I'm guessing it hardens back into gypsum.
You got it.
Cool.
That's why it's used for casts. You mix the powder with water, it forms a paste, and then as it dries, it hardens back into gypsum,
Okay.
creating that solid castum.
Wow, I never realized there's so much chemistry behind a simple cast.
Yeah, it's amazing.
So gypsum is like a chameleon, changing its form depending on whether it's holding onto those water molecules.
Right.
And what about those other salts we talked about, like washing soda?
Okay.
Does it have this water of crystallization too?
It sure does. The chemical formula for washing soda is Day2CO3.1H2O. That 10H2O means that there are 10 water molecules for each unit of sodium carbonate.
No way.
Yeah.
So that's why washing soda often feels a bit damp,
Yeah.
even when it's in a sealed container.
Exactly.
Those water molecules are just hanging out in there.
They are.
Wow.
Those water molecules are an integral part of its crystal structure.
Interesting.
It's amazing how something so seemingly simple as water can play such a vital role in the world of chemistry.
This deep dive is blowing my mind. I feel like I'm seeing the world in a whole new way. We've covered so much, from the basic definitions of acids, bases, and salts to the surprising ways they show up in our everyday lives. We talk about reactions, pH, the importance of balance, and even this fascinating concept of water, of crystallization. It's like chemistry is the secret code behind everything.
It really is.
And the best part is, we've only just scratched the surface.
Yeah.
I can't wait to see what other secrets we uncover.
Yeah.
But for now, I think we need to take a little break.
Okay.
And let all this information sink in.
Sounds good. It's amazing how all these seemingly separate topics are actually interconnected, isn't it?
Yeah, it really is.
It really underscores the point that chemistry isn't just something you learn in a textbook. It's all around us.
Right.
Playing a role in virtually everything we do and experience.
Absolutely.
You know.
I used to think chemistry was just about memorizing formulas and equations.
Yeah.
But now I'm starting to see it as this invisible force that shapes our world in countless ways.
Exactly.
It's pretty amazing.
And the more we understand it,
the
more we can appreciate the wonder and complexity of life itself.
Speaking of wonder and complexity, remember that challenge from the textbook about plaster of Paris?
Right.
The one about why it's called that?
Did you figure it out?
Of course. It's actually quite simple.
Plaster of Paris got its name because the gypsum used to make it.
Yeah.
Was originally mined near Paris, France.
Ah, so it's named after its place of origin.
Exactly.
That makes sense.
Sometimes the simplest explanations are the right ones.
Well, I think we've covered just about everything from the chapter.
Yeah, we have.
But before we wrap up this deep dive,
Okay.
I want to go back to something you said earlier. About how we've only just scratched the surface of chemistry.
Right.
What did you mean by that?
Well, we've talked about some of the fundamental concepts of acids, bases, and salts. But there's so much more to explore.
Like what?
For example, we could delve into the world of organic chemistry.
Okay.
Which is the study of carbon-containing compounds.
Organic chemistry?
Yeah.
That sounds pretty intense.
It can be.
What kind of things would we learn about?
Organic chemistry is the chemistry of life. It's the study of the molecules that make up living organisms.
Okay.
Like proteins, carbohydrates, and fats.
Wow, so it's like biology meets chemistry.
Exactly.
Interesting.
And it's a fascinating field because it helps us understand how life works at the molecular level.
Okay.
For instance, we could talk about how enzymes, which are special proteins, speed up chemical reactions in our bodies.
That sounds pretty amazing.
It is.
Are there any practical applications of organic chemistry?
Oh, absolutely.
Like what?
Organic chemistry is behind so many things we use every day.
Okay.
Like medicines, plastics, and even the clothes we wear.
Wow, so it's really everywhere.
It really is.
I'm starting to think that maybe we need a whole separate deep dive just on organic chemistry.
Maybe we do.
But for now,
Yeah.
let's stick with what we've covered today.
Okay.
Any final thoughts for our listener
Yeah.
before we wrap up this exploration of acids, bases, and salts?
Yes, I'd like to leave our listener with a little challenge.
Okay.
Now that you have a better understanding of acids, bases, and salts,
Mm-hmm.
take a look around your home or your neighborhood
Yeah.
and see if you can identify everyday phenomena that can be explained using the concepts we've discussed.
That's a great idea.
You know?
Like a scavenger hunt for chemistry.
Exactly.
Cool.
For example, you could try testing the pH of your soil,
Mm-hmm.
or even experiment with making your own indicators using natural ingredients like beetroot.
Those are great suggestions.
Yeah.
I might even try making my own indicator this weekend.
Cool.
It would be fun to see if I can identify different acids and bases around my house.
It's a fun and engaging way to put your newfound knowledge into practice.
Right.
And who knows, you might even discover something new.
Absolutely.
Oh.
So there you have it, folks.
Yeah.
A deep dive into the world of acids, bases, and salts.
Right.
Hopefully you've come away with a newfound appreciation for this fascinating field.
I hope so.
And the realization that chemistry is much more than just a subject you studied in school.
Yeah.
It's a dynamic force that shapes our world in countless ways.
Well said.
And on that note, we're going to wrap up this deep dive.
Okay.
Thanks for joining us.
Yeah.
Until next time.
Happy experimenting.
And keep exploring the world of chemistry.
It's all around us.
It really is.
See you next time.
Bye!